Fluorescent tubes. Here we have a diagram of the main components involved in the operation of a fluorescent tube. This is the tube itself, containing mercury vapour with a special phosphor coating on the inside of the tube. More about this coating in a moment. To start the lamp, we need to heat up the electrodes at the ends to ionize the gas within the tube. This is controlled by the starter switch. As soon as a current starts to flow between the electrodes, the starter switch will switch off. As more ions are created within the tube, it's easier for the current to flow, producing more ions, and so on. This could lead to a positive feedback, producing a runaway current. That is controlled by the ballast, which limits the current through the tube. There is an alternating current between the electrodes of the tube during normal operation, and this will be causing the ions and the electrons to travel back and forth along the tube. This diagram shows two of the atoms involved with the production of light. Here we have a mercury atom. I've just shown the inner electrons and the second energy level for clarity, and this shows an atom within the phosphor coating. Again, I've just shown the inner electrons and now a couple of energy levels. When the electrons are travelling through the tube, one of them can end up hitting an electron in an atom, like this, and raising it up to a higher energy level. When the electron falls back down to a lower energy level, it will emit a photon of light. For mercury, the majority of these photons are in the ultraviolet part of the spectrum, and so not visible to the human eye. However, what happens in the fluorescent tube is the photon emitted from this electron can end up exciting this electron, raising it up to this energy level. So, the ultraviolet photon is emitted, this electron drops down to its lower energy level, and this electron has now been raised up to this energy level. It could fall back down to here in one step, emitting another ultraviolet photon, or what can happen, it can fall down to here, like this, emitting a visible photon, and then fall down to here, emitting another visible photon. So in this way, we've converted an ultraviolet photon, no use for lighting a room, into visible photons, which are useful. This explains the efficiency of fluorescent tubes. So as we've seen, the ultraviolet photons are not wasted as thermal energy, but are converted into visible light by the phosphor coating. Normal filament light bulbs also emit a significant amount of ultraviolet light, but in the case of the filament light bulb, this is wasted energy. Fluorescence means to emit visible light due to the absorption of shorter wavelength light. That is what is happening in the coating of the fluorescent tube. Washing powders contain chemicals which can cause fabrics to fluoresce, the intention being to make your clothes look brighter in sunlight. But sometimes under ultraviolet lamps, certain parts of your clothes can glow very, very brightly, particularly the white parts. Paper also contains fluorescing agents, making it appear brighter. Banknotes do not contain fluorescing agents, and the test that some shops do is to place your banknotes under an ultraviolet lamp. If the banknote glows back at them, it shows it is a forgery. Phosphors are materials that emit light due to the absorption of radiation, the emission continuing for a noticeable time after the radiation has stopped.